Once upon a time, imagine a world with just one massive landmass surrounded by a single, vast ocean. This wasn't a scene from a science fiction movie, it was Earth about 300 million years ago. This supercontinent called Pangaea was a reality. It dominated our planet for millions of years. All the land we know today, from the Americas to Asia, was once unified in this gigantic jigsaw puzzle. Life on Pangaea was dramatically different from what we experience today. The climate was likely more extreme, with vast deserts in the interior and different weather patterns. The animals and plants of Pangaea would have spread across this giant landmass, creating a unique ecosystem unlike anything we see in modern times. The existence of Pangaea is more than just a fascinating fact, and it's a crucial piece of evidence that helps us understand the history of our planet and how it continues to change. The story of Pangaea's formation and eventual breakup is a testament to the incredible forces at work deep within the Earth. To comprehend the epic journey of Earth's continents, we need to delve beneath the surface, into the planet's inner workings. Beneath our feet lies a hidden layer, the Earth's lithosphere, which is broken into several large and small pieces called tectonic plates. Think of these plates as giant, irregularly shaped puzzle pieces that make up the Earth's outer shell. These tectonic plates aren't stationary, they're in constant, albeit incredibly slow motion. They drift atop the Earth's mantle, a layer of hot, partially molten rock. This movement is driven by the intense heat emanating from the Earth's core, creating convection currents within the mantle that act like giant conveyor belts, dragging the tectonic plates along with them. This movement, known as continental drift, is responsible for the dramatic reshaping of Earth's surface over millions of years. The interactions between these massive plates, colliding, pulling apart, or grinding past one another, are the driving force behind earthquakes, volcanic eruptions, and, most importantly for our story, the formation and movement of continents. Around 200 million years ago, the mighty supercontinent Pangaea began to crack and split apart, marking the beginning of a dramatic transformation of Earth's surface. The same forces that brought Pangaea together, the movement of tectonic plates, were now tearing it apart. As the Earth's mantle churned beneath Pangaea, immense pressure built up within the supercontinent. This pressure eventually overwhelmed the strength of the Earth's crust, causing it to fracture along massive fault lines. Molten rock or magma from the Earth's mantle welled up through these cracks, creating vast volcanic zones and pushing the separating landmasses further apart. This breakup wasn't a sudden cataclysmic event, but rather a slow, drawn-out process that unfolded over millions of years. The initial rifting of Pangaea created a long, narrow sea that gradually widened, eventually forming the central part of the Atlantic Ocean. This marked the birth of a new era as Earth's landmasses began their long journey toward their present-day positions. Section 4. The early stages formation of Laurasia and Gondwana. The breakup of Pangaea didn't result in the immediate formation of the continents as we know them today. Instead, it first split into two smaller supercontinents, Laurasia in the north and Gondwana in the south. This division, occurring around 180 million years ago, marked a significant step in the continental jigsaw puzzle rearranging itself. Laurasia consisted of what is now North America, Europe and Asia, while Gondwana comprised South America, Africa, Antarctica, Australia and the Indian subcontinent. These two massive landmasses continued to drift apart, separated by the expanding Tethys Sea, a precursor to the modern-day Mediterranean Sea. The separation of Laurasia and Gondwana had a profound impact on the evolution of life on Earth. Plants and animals that were once connected across Pangaea were now isolated on separate continents. This isolation led to divergent evolutionary paths, with different species developing unique characteristics in response to their changing environments. The breakup of Pangaea set the stage for the incredible diversity of life we see on our planet today. Section 5, A World Transformed, the Emergence of Familiar Continents. As millions of years passed, the relentless forces of plate tectonics continued to reshape Earth's surface. Laurasia and Gondwana, once dominant features, began to fragment further, eventually giving rise to the continents we recognize today. Around 150 million years ago, South America began to separate from Africa, creating the South Atlantic Ocean. This separation, driven by the upwelling of magma along the mid-Atlantic ridge, continues to this day, pushing the two continents further apart at a rate of about an inch per year. Meanwhile, in the northern hemisphere, North America was pulling away from Europe, widening the North Atlantic Ocean. This separation led to the formation of the iconic coastlines of these continents, shaping their unique geographical features. India, once part of Gondwana, embarked on a northward journey destined for a dramatic collision with Asia.